right, welcome to the world around us. This video is on physical properties of matter. Physical properties of matter. What are physical properties of matter? They are any attribute, quality, or characteristic of a material that can be observed or measured without changing the composition of the substances in the material. What? Okay, physical property of whatever this is, iron, are the things that you can observe about iron, whatever it is, iron or aluminum or whatever, or iced tea, the things you can observe about this without changing it into something else. So if I were to chemically change this into oxygen, hydrogen, and whatever, that would not be a physical property. It has to remain tea, it has to remain iron, it has to remain aluminum, it has to remain ice, water, steam for it to be a physical property. So a physical property, an attribute, quality, characteristic, blah, 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 that can be observed or measured without changing the composition of the substances. Okay, that's the difference between a physical property and something else that we'll talk about later on, chemical property. So physical property, it doesn't stop being soap. It stays soap. So there are lots and lots of physical properties. We're going to look at a few of them in this video today. We're going to look at a few of the things. First up is viscosity. Viscosity is one of those things that you probably don't talk about, but you've always known. You've always known what viscosity was, you just didn't have a word for it. So now you have a word for it. That word is viscosity. What is viscosity? It is the degree to which something is thick, sticky, semi-fluid in consistency due to internal friction. Okay, internal friction part, we'll get to that later. First of all, the degree that something is thick. Okay, you have seen soap. Soap is kind of thick. Soap doesn't flow as easily as tea. Honey, maple syrup. If you pour syrup on your pancakes, you want the syrup to be thick and you want it to go over those pancakes very slowly and drip down the side. That's viscosity. The internal stickiness, okay, internal friction, what that is that the molecules of the substance kind of stick to each other, and that's what makes it flow slowly. One way to think about viscosity is to consider how thick a liquid is. So let's take a look at our 3 sample liquids and see. Let's see if we can make any sense of this. This is the iced tea, this is antifreeze, and this is soap. It's iced tea, it's kind of shaky. Antifreeze appears to be a little thicker, and then soap appears to be the thickest. So we have not very viscous, more viscous. So the amount of, is it jiggly? Is it not jiggly? Is it thick? Soap is thick. Water. Tea is basically just water. Viscosity. The tendency of a liquid to keep it from flowing. Its resistance to flowing. The degree to which something is thick, sticky, due to internal friction. All right, conductivity. This one is going to be hard to see. It's easy to understand. There are actually 2 kinds of conductivity. Thermal conductivity is the degree to which heat is transferred, and then there is electrical conductivity, which is the degree to which electricity. And they're related. Most of the time, as far as I can recall, I cannot think of a case, things that are more conductive electrically tend to be, I'm saying tend to be instead of always is, tend to be more better conductors of electricity. And this is because of the way the conductivity works is the closeness of the molecules and the free electrons that are available, and then bumping into each other, and they transfer the energy or they transfer the electrical charge. Let's see if we can use my battery tester. So the way this works is, if the circuit is complete, the meter goes up. This is going to be hard. The circuit is complete, the meter is hard. Up. All right, we're going to start with the copper wire. I'm starting with the copper wire. All right, here we go. We're going to try this copper wire. So we can see that the electricity is conducted by the copper wire. Now, how about a rubber band? So I'm holding the rubber band onto the charger and onto the battery, and then when I touch it, what a surprise, the rubber band does not conduct electricity. The rubber band is not a good conductor of electricity. Conductivity, there's your conductivity for you. Thermal conductivity, the rate at which heat energy is transferred, and electrical conductivity is how the electrons are transferred. Does it conduct electricity? That is, does it transfer electricity from one side of the battery to the other? Does it transfer heat? So, yeah. Conductivity. Malleability. This is one that you kind of know, but you kind of don't really think about. If you hit something and it shatters, it is not malleable. If you hit something and it doesn't shatter, it is called malleable. So what might we have that we could safely hit? I'm going to go get some ice and a piece of aluminum. Turn that off. Turn on the 100. Let's go all the way. 240 frames per second. Because if you're going to smash ice, you might as well, get the most out of it that you can. All right, we're going to try to smash ice and see what happens. This could not possibly go wrong. I'm getting goggles because, it is a chemistry lab. Here we go. Is ice malleable? Well, I know ice does not behave well when hammered. How about aluminum foil? What happens if we hammer aluminum foil? By hammer, I mean use the back of a screwdriver. Hammering aluminum foil does not appear to shatter the aluminum foil, not even at 240 frames per second. I did smash my thumb. That was not, I wish I had goggles for my thumb. Malleability. Does it hammer without shattering, or does it not hammer without shattering? Malleability. Boom. That went in. That went in. Taking the goggles off because it is hot and they're fogging up. Frame rate, 24. Back on. There's water all over everywhere. I'm going to clean that off. Malleability. Does it shatter or does it not shatter when hammered? Does it shatter or not shatter? Next up, hardness. You kind of sort of feel this one out. You sort of know this. You kind of know this. But the technical definition is hardness of a material relates to the degree to which its surface can be penetrated. A measure of how resistant solid material is to various kinds of permanent shape when a compressive force is applied. Can you scratch it? Everybody knows diamonds are the hardest material on earth. Glass is pretty hard too, but if you run diamond down a glass, it will leave a scratch mark. So here we got wax, hard or not hard. This is a graphite pencil and wax. Will the graphite scratch the wax? Intuition, you're gonna go, yeah, of course it will. And the answer is, why, yes. The wax was scratched. You can see the scratch marks I left on the wax. You can see the scratch marks. Wax, copper strip. Will the graphite pencil scratch the copper strip? Now you immediately say, wait a minute, I see you made an X on the copper strip. You made an X. Except the X is the graphite that came off. There is no scratch on the metal. It is not scratched by the graphite. In fact, opposite took place. The copper stole molecules off of the graphite pencil, and that was the graphite leaving a mark. Hardness. The degree to which an object can be penetrated. So can the graphite break through the surface molecules of the copper and the wax? It did not break through the surface of the copper. Next, you know this one. You know this, melting and boiling point. Everybody who lives in an area that snows, we know that at 32 degrees Fahrenheit, that's the line. Above that, it's rain, because the melting point of water is 32 degrees. Below 32, it's snow or ice. We know melting and boiling points. So the best way to observe this is to put some ice in a pan, turn it on. You know what's going to happen. You can imagine that, and I will save the video time. Density. Density is the ratio of an object's mass to its volume. Density. Density is the ratio of a substance's mass to its volume and can be expressed mathematically as density equals mass divided by volume. Density results from the number of protons, neutrons, and electrons. So how close are they jammed together? So here we have two blocks, obviously the same size. They are the same size. And looking at them very closely, we find these two blocks have the same size in all dimensions. If something has the same size in all dimensions, length times width times height, it has the same volume. So we have a identical volume on these two blocks of metal. The mass, though, because the electrons, neutrons, and protons in this are much closer together, and there's more of them, and they're more densely packed, this guy weighs in at a hefty 248.8 grams. The other contender weighing in at only 90.6 grams. So we have two blocks of the same volume. The volume is the same, their volume is the same, but the mass is very, very different. The mass is very different. All right, I got a big mess to clean up, so you don't have to watch that. Let's run quickly through a few physical properties. Also, bonus physical property. Is it magnetic or is it not? We call that is it magnetivity? Does it have, yeah, that's magnetic. Guess what? Aluminum, not. Iron, magnetic. Safety goggles, not. You'll have to trust me, there's no way for you to feel the connection. Magnetivity is another. There are lots and lots of physical properties. We went through a few. Viscosity, tendency to keep from flowing. Conductivity, does it transfer electricity? Does it transfer heat? Malleability, can you hammer it or hit it with the back of a screwdriver without it shattering? Hardness, will the surface be penetrated, that is scratched by something else? The degree to which the surface holds itself together. Melting and boiling points, and then density, same size, different masses. This is more dense. We kind of looked through these things. So there you have it, physical properties of matter. Hope you enjoyed the video. If you did, please subscribe to the channel, click the like button, leave me a comment, question, sign up for notifications, and thank you for watching. We'll see you in the next video.